There's a barndominium tucked into the Texas Hill Country with a 22-foot wall of glass that vanishes into a pocket in the wall in under 10 seconds. It turns an entire great room into an open-air pavilion. It costs more than most people's kitchen renovation. And for nearly 4 months of the year, the family who built it can't use it the way they imagined. Stick around, because the reason why says a lot about how this design trend actually works, and it's not what most home shows tell you. Before we get into it, if you're into real numbers behind unusual homes, hit subscribe, tap the bell, and give this one a like so more of these breakdowns find you. Now back to that glass wall. Indoor-outdoor living isn't new. Architects have been chasing the disappearing wall since the mid-century modern era, when case study houses in California used floor-to-ceiling glass to erase the line between the living room and the patio. What's changed is the hardware, the price point, and who's asking for it. Industry analysts tracking home design for 2026 describe indoor-outdoor connectivity as the single biggest force shaping how new homes get laid out this year. Not a boutique feature for architects' own houses, but a mainstream expectation showing up in production floor plans, custom builds, and yes, barndominiums. The core idea is simple: expansive glass, sliding or stacking door systems, continuous flooring that runs the same material from the kitchen to the patio, and covered outdoor rooms that read as an extension of the house rather than an afterthought bolted onto the back of it. For a barndominium, this pitch is almost irresistible. You're already building with a steel frame or post frame shell that favors big, uninterrupted spans. You're already leaning into an aesthetic that blends rustic materials with modern glass and steel. Cutting a 20-foot opening into a barn-style structure and filling it with a disappearing glass wall doesn't fight the architecture, it completes it. So the homeowners in the Hill Country did exactly that. And on paper, it should have been the signature feature of the house. Their barndominium sits on a ridge with a view west across a limestone canyon, the kind of sunset that real estate photographers wait around for. The great room, kitchen, dining, and living space combined under a vaulted metal ceiling, faces that view directly. Instead of a standard patio door, the design called for a multi-slide glass wall system. Large tempered glass panels, roughly 4 to 6 of them, running on a top track and stacking to one side, with the option to pocket fully into the wall so no panels are visible at all when open. Systems like this aren't cheap. For a typical opening in the 12 to 20 foot range, multi-slide or pocketing glass wall systems from manufacturers like Western Window Systems, La Cantina, or Fleetwood generally run somewhere between $15,000 and $50,000, depending on panel count, glass specification, and whether the track pockets into the wall or simply stacks against it. Folding, accordion-style systems land a bit lower, often $12,000 to $35,000, though they don't disappear as cleanly. You can still see the folded panel stacked at one end when the wall is fully open. The homeowners chose the pocketing version. 22 feet of glass, fully retractable, engineered so the great room and the covered porch outside become one continuous space with a matching polished concrete floor running underneath both. Structurally, it works exactly as promised. Visually, it's the kind of shot that gets a house onto every barndominium page on the internet. The problem showed up in August. Metal buildings behave differently than a traditional stick-framed house, and that difference matters enormously once you start cutting big glass openings into them. Steel conducts heat fast. It also cools fast. That means the same wall panel that feels dramatic and modern in photographs is, thermally, one of the most volatile surfaces in the house. HVAC specialists who work specifically on barndominiums point out that metal shells create their own set of climate control challenges that don't exist in conventional homes. The walls and roof absorb and radiate heat quickly. High ceilings mean a much larger volume of air to condition, and open floor plans make it difficult to keep temperature consistent from one end of the house to the other. Add a 22-foot glass wall directly into that envelope, facing west, and you've introduced a heat gain and heat loss problem on top of an already sensitive structure. In the Hill Country in August, afternoon sun hitting unshaded west-facing glass can push interior temperatures near that wall dramatically higher than the rest of the house, forcing the HVAC system to work far harder just to hold the room at a comfortable set point. The family found themselves closing blackout curtains over glass they'd spent tens of thousands of dollars making disappear. In winter, the opposite problem appeared: cold radiating off the glass at night, Made worse because metal frame structures are especially prone to condensation where warm, humid interior air meets a cold surface. Builders and insulation specialists who work in steel frame construction describe this as one of the defining risks of the format. Moisture depositing on cold metal or glass, which over time can lead to mold growth, corrosion of structural fasteners, and damage to interior finishes if it isn't controlled. Nobody had built in a shade strategy for that specific wall. Nobody had accounted for how a 22-foot opening changes the humidity load on the HVAC system when it's used the way it was designed to be used. Open, for hours at a time, on the exact humid Texas evenings when people most want to sit out there. So the family ended up with a beautiful glass wall that they used constantly in April, May, September, and October, and largely avoided the rest of the year. Not because the wall was defective, because indoor-outdoor design in a metal building isn't just a door swap. It's a climate control problem, wearing an architecture magazine's clothing. Here's the part almost nobody explains before you sign a contract for one of these walls. The glass isn't the expensive part. Making the glass work in your specific climate, on your specific orientation, is the expensive part, and it's usually left out of the budget entirely. That's the actual story behind indoor-outdoor barndominiums in 2026. It's not a design trend. It's an engineering discipline that's been repackaged as a design trend, and the homes that succeed at it look effortless specifically because someone solved 5 invisible problems before the glass ever arrived on site. So what does it take to make a wall like this actually livable 4 seasons a year in a structure that's thermally unforgiving by nature? That's where this gets interesting. The fix starts before the framing is even up with orientation. Builders working in hot climates increasingly treat solar exposure as the first design decision, not an afterthought, meaning the big glass wall goes on the north or east elevation where possible, or gets paired with real shade if it has to face west or south. A minimum of roughly 6 feet of overhang is a common rule of thumb cited by outdoor living designers specifically to keep low afternoon sun from blasting directly through the glass and turning the room into a greenhouse. That overhang used to just mean a fixed patio roof. In 2026, the more advanced version is the bioclimatic pergola, a structure with motorized aluminum louvers that rotate to adjust for sun angle, ventilation, and rain, effectively turning a static roof into a responsive one. Pair that with integrated infrared heaters and retractable insect screens, and the covered zone just outside the glass wall becomes usable in far more months of the year than an open patio ever could be, without requiring the glass wall itself to be open constantly. Second, the building envelope has to be treated as a single connected system rather than a wall here and a door there. For steel frame and post-frame construction specifically, closed-cell spray foam has become the default recommendation precisely because it does 2 things at once. It delivers a high R value, generally in the range of 6 to 7 per inch, and it forms an air and moisture-tight seal directly against the metal, which is the surface most prone to condensation. Insulation specialists who work in this niche are blunt about it. Address the building envelope before drywall goes up, because retrofitting a condensation problem after the walls are closed is far more expensive than solving it during framing. Third, and this is the piece that gets skipped most often on a tight budget, mechanical ventilation. A well-sealed barndominium is airtight almost by definition, which is good for energy bills and bad for trapped moisture unless there's a dedicated way for stale, humid air to leave the building and fresh air to replace it. Ventilation specialists recommend an energy recovery ventilator, or ERV, specifically for tightly built homes with large glass openings, because it exchanges indoor and outdoor air continuously while recovering most of the energy that would otherwise be lost in the process. Skip this step, and you get exactly what happened in the hill country: moisture with nowhere to go, condensing on the coldest surface in the room. Fourth, the HVAC system itself needs to be sized and zoned for the specific reality of an open-plan metal building with a big glass wall, not sized the way a contractor might size a conventional house of the same square footage. Because open floor plans make it difficult to hold consistent temperatures across the space, and because glass walls introduce concentrated heat gain or loss right at that one elevation, HVAC designers working on barndominiums increasingly recommend multi-zone mini-split systems, or a central system with independent zone control, so the area near the glass can be conditioned differently from the rest of the house, rather than fighting the whole system to a single average set point. Run the math on a mid-sized barndominium, and the pattern holds up. Builders working on energy-efficient metal home projects estimate that upgrading from a standard bat-insulated shell to a package of spray foam, a high-efficiency CR2, rated heat pump, an ERV, and rooftop solar add somewhere around $30,000 to a build, but can cut annual energy costs by roughly $3,500 a year at typical national utility rates. A simple payback in the range of 6 to 9 years once federal solar tax incentives are factored in. That's not a guess pulled from a brochure. That's the kind of return that shows up when the mechanical system is actually designed around the architecture instead of dropped in afterward. Picture a different barndominium, same climate, same ambition, but the sequence done in the right order. The great room glass wall faces east instead of west, catching soft morning light instead of brutal afternoon sun. A bioclimatic pergola extends 12 feet off the exterior wall, its louvers closed against midday heat and open at dusk to let the space breathe. The polished concrete floor runs from the kitchen island straight through the glass opening and out under the pergola, using the same score pattern and the same sealer, so the eye reads it as one uninterrupted surface rather than two rooms pretending to be one. Outside, an L-shaped outdoor kitchen anchors the covered zone, a built-in gas grill, a small refrigerator, stone countertops that match the interior's material palette rather than fighting it. This isn't a decorative flourish. Well-designed outdoor kitchens are consistently cited as one of the higher return additions in outdoor living, with estimated returns on investment ranging from 60 to as much as 120% depending on build quality and location, because they extend genuinely usable living square footage at a fraction of the cost per square foot of adding conditioned interior space. Inside, the ceiling holds a whole home ERV, quietly exchanging air, sized specifically to handle the added humidity load of a room that regularly opens to the outdoors. The HVAC system runs as 2 zones instead of 1, so the great room can run a few degrees warmer in summer without making the rest of the house uncomfortable. And the glass wall itself sits on a track that pockets fully into an insulated cavity in the wall, not just stacked to one side, but gone. So when it's open, there's no visual seam between indoors and out at all. What the homeowners gain here is real. A living space that functions as roughly double its square footage for a large portion of the year, a covered outdoor room usable in rain or shade, and a house that photographs and lives like it belongs in the landscape rather than sitting on top of it. What they sacrifice is also real. A meaningfully larger upfront budget, a longer and more technical design phase that requires an HVAC engineer and an insulation contractor at the table early, not just an architect, and ongoing maintenance on tracks, seals, and mechanical ventilation equipment that a simpler house wouldn't need. So is the 22-foot disappearing glass wall worth it? The honest answer is that the glass was never really the risk. The risk was treating a mechanical and thermal engineering problem as if it were purely a design choice, picking the wall first and figuring out the climate control afterward. Homes that get this right don't do it by spending more money everywhere. They do it by spending money on the invisible parts first: orientation, envelope, ventilation, and zone mechanical systems. So the visible part, the glass, the continuous floor, the shaded outdoor room, actually performs the way it looks like it should in every season, not just the 2 mildest months of the year. The bigger lesson underneath all of this applies well beyond glass walls. In a barndominium, almost every dramatic, magazine-ready feature is sitting on top of a metal shell that behaves differently from the wood-framed houses most building conventions were written for. The homes that end up loved rather than merely photographed are the ones where somebody asked the unglamorous question before the exciting one. Not, how big can we make this opening, but what does this opening do to everything else in the building once it's built? That same instinct, solve the hidden problem before you fall for the finished look, is exactly what separates a barndominium that works from a kit that just gets assembled. Next time, we're looking at prefab kits you can actually order and put up fast, and which ones are worth the shortcut.